So we're going to do some tours of the standard library this afternoon and look at a few useful modules. All of our tours can be relatively quick and short, and I also want to do one run through of tools. Make sure I do that. In fact, I might do that first. Let's do the tools first so I make sure I don't forget. So tools I use every day. I've already got most of you set up with IPython, and I love IPython for just playing around. There is a PDB equivalent to IPython. You may have noticed if you run some PDB sessions that PDB is pretty bare bones. There is iPDB. You can get it with easy install. And iPDB works just like PDB, but has a few additional niceties like tab completion and syntax highlighting and that sort of thing. So as you're exploring your code, printing out your structures and whatnot, it's just a little bit easier on the eyes and easier to read. It's not related to IPython in any way, shape, or form, but it's the same thing as IPython to the shell and iPDB to PDB are pretty equivalent. Easy install. We've also talked about easy install. Easy install is a Python program that provides you with a command line tool to install other Python programs. And easy install is hilariously hard to install. You need to go download it, extract it, run it, set up, or maybe your operating system packages it yourself, which if you've got a nice operating system, it does. Or they provide a executable installer for Windows. Once you have easy install, what you have is a command called easy install. And it takes packages to install. So you need to know what you're looking for. You can specify versions with an equal sign. So if I wanted to get a specific Django version, I could say Django equals 1.0. And it would find Django 1.0 for me. Notice I'm trying to install easy install right now, and it gives me a permissions error. So the default thing easy install does is it installs to your site-wide system packages. And this raises kind of an interesting question. What if I want to have Django 1.0 installed and also Django 1.3 installed? Then when I do Django, import Django, which one do I get? I can't have more than one version of the same package installed at the same time. They've got the same name. They clash. So it would be nice not to be installing packages, especially ones that I'm going to try out, or especially ones that are just for one particular script, into my site-wide system packages library, which is what easy install does by default. We can get around this with a tool called virtualenv. It stands for virtual environment. And virtualenv is basically a bash script or a Windows batch script, depending on your OS, that sets a bunch of environmental variables and fakes Python out so that Python looks for and installs things to someplace other than your system packages directory. And you can use virtualenv, it's a command, directly. And I'm going to do that now to create a virtualenv, and I'm going to call it labs. And you'll notice it says it put a new Python executable in labs/bin/python. It installed Setuptools. Setuptools is actually the package that contains easy install. And when I look at my current environment right now, I can see I've got a directory called labs. And I look in labs, and I can see I have a bin directory, an include, and a lib. I can activate my virtualenv from here by saying source labs bin activate. Don't pay too much attention to this because I'm going to tell you a way easier way to do it in a second. But you'll notice that it changed my command prompt to say labs. It indicates that a particular virtual environment is installed. And a minute ago, when I tried to install Django, it said, oh, you're not root, so I'm not going to install it in your system-wide site packages. Now when I do it, easy install respects my virtual environment. And it installed, for instance, the Django admin script that you use in the bin folder of labs. It installed this egg, which is the kind of zipped up distribution of Python files, not in my global site packages, but in my labs site package. And as long as I have this virtual environment open, I can access Django. But once I turn it off, there is no Django installed in my system site packages, and I can't import it. And what that means is every virtual env is distinct, and I can install a bunch of packages, and some of them have bugs, and they're different versions than the ones I want. And I can just nuke it. And I didn't mess up my system. I didn't install competing packages in my system. I didn't change anything at all about my system just now. So that's really handy. There's a helper script that is virtual env wrapper. This is a project of Doug Hellman of Python Module of the Week fame. And virtual env wrapper simply provides you a bunch of convenience functions around virtual env. So for instance, instead of saying virtual env labs here, I'm going to say make virtual env lab. It didn't put it here. It puts it in a dot directory in my user folder, which I can change if I want to change with a preferences file. It gives me a utility command called work on. And when I work on, I can see I've got several different virtual envs defined. Those aren't directories in my local path. Those are virtual envs I've made with virtual env wrapper. So I was using duplicity, which is a Python-written encrypted backup program. And I installed it in a virtual env. Because I wasn't sure whether I wanted the development version or the stable version. Same thing goes with RST to PDF. A bunch of tools for converting restructured text to various other formats. And I'll say lab. And you notice it activated my virtual env for me. I didn't have to do the whole source bin, activate, whatever thing. And if I wanted to work on a different one, I could just switch. And as usual, I can deactivate. And again, the benefits of virtual env are you don't have to be root. You can install things in a user directory. You don't mess up your site-wide Python install, which it is entirely possible to install packages that then make every single instantiation of Python bomb. You don't want to do that. And it just gives you a Scratch playground. So useful tool. I use that all the time, both for development and for deployment. Other tools I should mention. It is, because it's basically just setting a bunch of environmental variables. So it's not actually, using anything different. It's just doing some path mangling. And you can achieve a lot of the same effects by importing sys.path and adding a specific path to sys.path and manually passing a -- prefix argument to easy install. There's ways to do everything it does, but it hides it all inside of some bash wrappers for you. And yeah, every client that I have is on production in virtual envs right now. So including people I'm not in charge of production for. It's a well-established Python tool.
Virtual env will pick the parameters like a lab, and create a subdirectory.
Yeah, so you missed a tiny bit. Virtual env will make a new Python environment for you, and then there's another program called virtual env wrapper, which is by Doug Hellman. And it'll automatically create the virtual envs for you. It kind of hides their location. It doesn't put them in the current directory. And it gives you that whole menu thing where you just say, work on. And with tab completion, I can see that I've got several defined, and I can pick which one I.
OK, so all these things were defined in the wrapper setup, which make virtual env were used to create the local environments, right?
Yep. pep8.py. I wonder how I'm doing. Let's look at some code. here's classmates number 9, and I don't remember exactly where I was in this, but I'm reading from a CSV file up here at the top, not inside of a function or anything. I've got functions as save to files, display a list, print a record, get a record, query a record, add a record. Everybody else has code like this, right? Filter by a role. I'm storing my menu in a dict with tuples of functions and descriptions. And I have a endless loop in main. Well, that code should look really familiar to everybody. Yeah, that's not too bad. So I run pep8.py on my file, my Python file. You can install pep8. Let's see if this is true. Notice I just tried to work on pep8. There isn't one. It tells me what to do. Automatically activates it when I created it. This is the virtual env wrapper, Doug Hellman's script. Can I easy install pep8? Yes, I can. So if you have easy installed, you can get pep8 trivially. I think I actually downloaded the development version of pep8 and have it in my user bin directory, but whatever. Let's look at that listing again. Classmates9.py. It only has a few comments. On line 15, it specifies the warning or error number for each one. And if there are some places where you disagree with pep8 or the coding standard of the company you're working for is different than pep8, for instance, pep8 expects you to have no lines longer than 80 characters. And maybe the company you work for says, hey, everybody has big monitors. You can go to 100 characters. You can disable specific errors or warnings in a config file or with command line options. That's what the identifier is for. But it tells me I have trailing white space on line 15. And it's true. I'm going forwards there. And you don't see the characters because they're spaces, but you'll note I can go through 4 spaces. So I'm going to delete that line and hit enter. Resave my file and run it again. OK, that one went away. Now it's complaining about line 16. Expected 2 blank lines, found 1. I'm on line 16. And the pep8 standard, by the way, is you only need to put a blank line between functions. It's kind of hard to read if you cram your functions together like that. Doesn't that clear sense of separation? So you need a blank line between functions and 2 blank lines between classes. And I think it's 2 blank lines here is 2 blank lines between procedural code and the start of my functions. And I probably ought to put all this in a function anyways, but I was in the middle of things. It's going to complain about lots of trailing white space. So I'm going to delete all my trailing white space and see what it says. 23, another 2 blank lines, found 1. Maybe it does want 2 blank lines between every function. I was thinking it was just 1 between regular functions. You know what? It might be 1 between methods in a class. And also, line 62, a different kind of error. White space before comma. Oh, I've just been adding some spaces, so the line count is off slightly. But look at this. Python style is commas in a list are butted right up against the object that they're after. But then there's a space before the next one, just like English syntax. So if I take out all the spaces, it ought to complain about that. Yeah, I'm missing white space after comma. So it's being totally anal, but it will verify that your code is all formatted exactly the way it's recommended by pep8. So useful tool, just a style checker, and I don't use it that much. There's also Pilant. And Pilant is not just a style checker. It's kind of a quality of code evaluator. It's also way more verbose. So for instance, it says invalid name classmates. It's complaining about my file name, and its opinion is modules and classes are supposed to be named slightly different than regular functions and expressions. I disagree, and I believe you can suppress specific warnings with Pilant, but I forget how to now because I usually just do it in my config file. It doesn't have much else to say. Pilant doesn't have much else to say here. It runs a duplicated line checker, which will detect if you've been like copying and pasting the same function repeatedly throughout your code, and is usually a sign of badly written code. So that's kind of useful. It also catches things like general quality. I don't have doc strings in everything. I don't have any comments at all. Not many empty lines. Those are just kind of raw metrics. And also basically tells me what I have. I've got a module. There are no classes, no methods. Interestingly, it says that there are no functions. I'm not sure why. That's messages by category. Pilant is kind of useful is kind of more useful run on large code bases. And sometimes we'll detect duplications in code, which is usually there used to be this function, and then we renamed it and wrote a new one and did never take the old one out, which is usually a problem of some kind. So I do run Pilant a little more frequently than I run Pep 8 because my code is mostly Pep 8 compliant anyways. That's it for tools. And the important ones are easy install in virtual env. And if you have a sane operating system, it may offer to install Python packages for you. For instance, I'm running Ubuntu here, so I could probably see if my package manager has Django packaged for Ubuntu, which it does, in fact. And I would strongly recommend against using operating system packages for any Python package you're going to do development work with, because it will probably put it in a non-standard place. It probably is an older version, like it's really hard for operating system that has a, like Ubuntu that has a release schedule. I'm on a long-term stable version at the moment, I believe, of 3 years to have like the latest and greatest in software. And you probably want the latest and greatest version of Django if you're going to develop against it. So don't use the built-in packages for the most part. Get easy install. Use easy install. And don't install packages system-wide unless you know for sure that every program you ever write is going to want to use that package. Or alternatively, the installation process is really, really painful. So my one exception to using easy install is Python Imaging Library, which is a graphical manipulation program you can use to resize images, among hundreds of other things. And it involves a C compilation step that takes a while. So I install that system-wide, and then I install everything else in virtual envs when I'm working on things. Oh, and also the Postgres database driver I install system-wide. Again, it is a complicated install. I'd just like to do it once. But especially anything that's pure Python code, you might as well just download it and put it in a virtual env. No, so you don't have to worry about this on Windows, but Unix and Mac have a built-in listing of programs that you can install for your operating system automatically. They'll go and download and install them. So Ubuntu that I'm using has a command apt-get that will, if I say apt-get program name, it'll automatically go download it. It's been packaged for Ubuntu. I'm pretty much guaranteed that it'll work appropriately. I don't have to go download like an executable installer or anything. And that's a great feature. I mean, if I want a new text editor, I just install it from the command line. But don't use that feature, that great feature. Don't use that for Python libraries. And in the case of Windows, you don't have to worry about it anyways because Windows doesn't have that great feature built in. So if you use Ubuntu, in general, don't use Ubuntu's. So Ubuntu has a... No, I'm talking about your operating system. Okay. Yep. So you might have used like Synaptic on Ubuntu. Yes. And Synaptic, it's great for installing programs, but don't use it for installing Python modules. And last advice is everybody ought to be running Linux. And I guess you could fall back to Mac if you really had to. So enough about tools. And those aren't all the tools I use. Obviously, I'm a big fan of Emacs, and there's a bunch of Emacs integration stuff that I could talk about for forever. But those are the Python-specific ones that are cross-platform. You can use them no matter what your editor, operating system, or area of work is. Let's do a Octoparse sample. And if you want to add some options, either to a toy script just to see how it works, or to your classmates file, you can do that. And we'll see how long this takes, and I'll circulate again and see how people are doing with their labs. And is anybody planning on leaving early today? Everybody's gonna be here till at least like 4?
Yeah.
Okay, cool. I'll put up the survey thing here in a little bit, but you don't need to take that till you're getting close to leaving. But I do want to make sure I don't miss anybody with that. So we've already demonstrated one method of seeing your command line, and by that I mean how your program was invoked from the command line with Python. So if you import sys and you print sys.argv, you get a list of all the command line options to your program. And as it happens, the program you're actually writing is Python, and my Python script is the first option. If you do things like this, let's just do those two. Sys.argv does show them to you. Now I've got 3 command line options on my program, the name of my script, a string, and another string. It doesn't actually parse them out for you. It's extremely common for console users to use programs that have tons of flags and arguments to do things. We've already been doing that with Python a little bit. We've briefly discussed the -m switch, and you can say Python -m pdb, and it'll start pdb when it starts running my script. So that's a command line flag to Python.
The following ones is just the input file that your Python program is going to take, right?
Yes.
What is the backup for?
So obviously nothing's happening right now, but I'm just imagining what options you might want to add to your classmates. And you might want to pass the name of the file that you're going to read and write data from as an option. You might want to use backup to say, when you go to write, save a copy of it first as filename.foo1.csv before you write to it. I'm just guessing at what sort of options we might want to add here. And demonstrating that the sys.argv doesn't do anything smart at all. It just breaks up by spaces the arguments that it's passed and gives you the ability to see them. And if you want to intelligently test whether or not a file name was passed to your script, and you're just using sys.argv, you'd have to look and see if there's a -- file name equals in any of the strings in the list. Parse it out yourself, and that would be really painful and annoying. I was going to say that Python also has a -v command that dumps a bunch of debugging and is occasionally useful when you're curious what library it's loading automatically or what libraries are being loaded. And it tells you all that, as well as its version. So option parse, Octoparse, is the answer for parsing your arguments. And I should note that Octoparse is deprecated as of Python 2.7. It's included. It's not going away. You can feel free to write against it, and I'm going to tell you about it. All my deployed Python code is on 2.6 or 2.5. I have some stuff that's on 2.5 because that's still standard on CentOS. So I haven't switched to argparse. And argparse is similar to Octoparse. Basically, they just wanted to break backwards compatibility and wanted to leave Octoparse the way it is. So Octoparse won't go away, and I'm going to show you how to use Octoparse right now. And the way you use Octoparse basically is you've got to import it. You create a parser. You add options to your parser. And then you ask your parser to look at the command line and give you back all the arguments and all the options that were passed. And for free, you get some nice functionality. So let's say this. And it's worth noting, module docs and a simple usage example is available right from help. You don't need to go anyplace else to figure out how to use it. And all we're going to do is make ourselves an opt parser, ask it to parse the args. It returns, actually, let's catch it. It returns a tuple. And we're going to print the tuple. So we haven't added any intelligence whatsoever. Notice the default thing is the tuple is a dictionary and a list. Despite the fact that we have one argument as far as sys.argv is concerned, we have no arguments as far as option parser is concerned. It figures you don't need to know the name of your script, probably. And the contents of the tuple are enough to let us know that we're going to get back options, which are keyword named, and args, which are positionally named. If I now try to pass some options, notice the first line is my sys.argv being printed, and I now get a helpful usage string. Well, not so helpful yet. Usage, toy.py, options, and then error, no such option -- file name. And what Octoparse is basically doing is we specify what options it is that we accept. The ones that we specify, it will search out and parse for us, and anything else it will consider to be an error. So let's specify some options. And I should note, almost anything else. If you do -h or -- help, if your program is using option parser, it will print out a help message, which you can customize, obviously. So you get one option for free. And -h and -- help are standards on the console command line in most of your Linux commands. Except probably the really old ones. I wonder if easy install has a -h. Yes, it does. I say easy install -h or easy install -help, and it shows me all the flags that it accepts. So let's add some options to our parser. We add options just by specifying how they can be passed, and I'm going to specify 2 ways for all of them, which will give me a nice fluent command line interface. Let's just do that much. And our tuple went away, so I'll print it out. OK, now when I say toy.py -f toy.csv, the first line is, again, sys.argv is separating everything by spaces. And it sees the space between -f and toy.csv. So if you were parsing the sys.argv and you wanted to accept just a single dash flag, you'd have to look for successive arguments. Your parsing job would get to be a little bit complicated. Notice I didn't say file on the command line. But option parser knows that -f and -- file indicate the same option, handles the space, and goes ahead and sets a keyword in my dict of options. So that's simple. If an option exists, the options represents as a dictionary, but I can access it as objects. So just dot notation. If options.file. The add option function takes a bunch more things, including I can coerce it to a data type. So like if I want to get integers passed, say I want to say quality, because I'm writing an encoding script. I'm going to have to convert that to a number. I can specify in my option that it should be a number, and not only will it convert it to an int, but it'll also complain nicely if the user passes a non-integer version. It's also smart enough to add the options I've defined to the usage. I say .help, and now, and just because we've seen that enough, I'm going to take out the argv. And now it says, I still haven't customized my usage string, and I still haven't customized my help message at all. But it does note that I take option f file or --f equals file, and I should demonstrate that I can do either style of option handling, and the result is identical. So command line programs frequently take either a single character and a dash, which represents a flag and very frequently doesn't have a value, but confusingly sometimes does, or more understandably, I think more widely approved of, is 2 dashes and name equals value.
How does input the -f and the -file like a predefined thing that you're just pulling from? Or is that being defined by you and
That's being defined by me. So the options that you want to accept can be anything that you want. The only one that option parser forces on you is -h or --help, and you can't define a --help option.
So just whatever when you have options dot and then the --stuff has to match. Is that how it links them together?
Yep. So this command right here, I said I'm adding an option, and it is -f or --file, and it specifies I can accept -f, and it gets the name from the --f. If I didn't specify the --f part, I think this is an error. Yeah. There we go. Notice I didn't specify the --f. And in this case, I get a runtime error. I'm getting my options file, that's all. There we go. In which case, the name of my option is just -f. If I provide a long name, it'll use that by default, and it'll also use that in the help. If I just provide a short name, it doesn't really know what to call it. It's just capital F, which isn't very helpful or informative. So it's always nice to provide a name for it. You can optionally say dest equals file, which will give it a name. You can see now it says -f equals file instead of just capital F. But I never bother with the destination because I always allow either short or long opt passing style. You can also, there's just a couple of other things that might be useful. You can define a default. So you can even skip the whole if there was a file, then you know that there will always be a file passed in. Either the user will pass one in with a flag, or you'll optionally get the default. You can also, we talked about storing types. You can also define the action parameter. And action by default is store, which means create an option of name, long option type, or destination, and put whatever the user typed in there, converting it if I specified a type. But action can also be things like store true, in which case, let's add a store true option here. Now notice, again, I have an additional line in my help, -b or -- backup, no equal sign, because I specified store true. What store true says is the user isn't going to pass a value. He's just going to pass the flag. So no value, but backup equals true. No value, but backup equals true. And this, in fact, would be how I'd want to use this. I might say file equals toy.csv and backup. And I don't want to say backup equals true. I just want to say backup. Or more likely, once I'm used to using this program, I'd say something like -f toy -b. Sorry for the highlight there. And again, just from this much, -f toy.csv -b, it can say that I do want to make backups, and that the file option that was passed in is toy.csv. And arguments are positional. So anything after your flags without dashes are positional arguments. And if the file option was mandatory, like we didn't have any sort of default, then I probably wouldn't make the file be an argument, and I'd probably make it be, or I wouldn't make it be an option, I'd make it be an argument. Option parser does not, I don't think, let you define your arguments, only define your options. But of course, if I could type, I could fix that. And my program would complain if I didn't pass it a file name as an argument. OK, super simple. I've only added to my program 4 lines of code. And then to handle my options, I simply say dot notation. It's an object. And the only other thing I should show you is that you can customize the usage string. And it has kind of a funky format. not even using my usage. There it is. It didn't like my format before. Oh, and that's what it is. It does provide the usage argument automatically nowadays. Okay, so that's slightly more user-friendly as I customize the usage line to say this is how you're supposed to call the program. So it's kind of counterintuitive to say you can make user-friendly command line programs because, hey, it's still a console. But you can make somewhat user-friendly command line programs that describe how to use themselves. They show a listing of all their options that you didn't have to write. It's generated automatically for you. They make sure that what the user is passing are legitimately defined options and arguments and make it easy for you to access those values. So if you'd like to work on option parser, you could go ahead and add an Octoparse front end to your classmates, or feel free to just work in another file and play with it. But hey, the file makes sense, and you might also try a backup flag, which when you write would make a backup copy of your CSV file before you write over top of it. And I'm just going to circulate again and see where people are at in their labs.